Indiana University East Chemistry C105, C108, C101. Examples of calculations involving the mole. In this video, we are going to look at a few examples of calculations where we're trying to relate the number of moles of a substance with the number of atoms of a substance and the mass of a particular substance. And the key to all of these problems, doing all these problems, all stoichiometry problems, or most of them that you see is to use dimensional analysis. And specifically, have a good idea of where you want to go and where you want to go from. So let's look at a couple of examples. So firstly, I want to find the number of moles and number of atoms in 20.0 grams of potassium. So let's look at part A. The number of moles of potassium, well, we'll start with 20.0 grams of potassium because that's the amount we have. And we want to get rid of grams and we want to go to moles. Well, the number of grams per mole for each mole is the molar mass. So that's 39.10 grams per mole. And that comes out to be 0.512 moles. As a result, we can find the number of atoms. Okay. And if I start from 20.0 grams, and this time I can't get directly from grams to atoms. So I need to go to moles first. In all stoichiometry problems, you really need to get to the mole. So I have 39.10 grams per mole. And then I know that in each mole, that's 6.022 times 10 to the 23 atoms. And therefore, it is 3.08 times 10 to the 23 atoms. So there are that many atoms in 20.0 grams of potassium. Let's look at a bit more complicated example. Here, I want to determine the identity of this element. And to do that, I need to figure out the atomic mass or the molar mass. So I want the number of grams per mole. Now, we know the number of grams of a particular sample, so it's 0.815 grams. And moles are related to the number of atoms, right? We know that. So it's 4.61 times 10 to the 21 atoms. So we have the grams per atom. So I want to get rid of atoms and convert that to moles. How do you do that? Well, you use the Avogadro's number and say 6.022 times 10 to the 23 atoms per mole. So now I can cancel atoms and I get grams per mole, and that's 106 grams per mole, which turns out to be palladium. So we've done a few examples here, and all of them basically center around doing dimensional analysis. So please, if you need help, please seek help. You need to do plenty of practice to get good at it. And if you don't practice, you will not understand this, because we're going to go on and do more complex problems of this type as we carry on in this course. Thank you.